Hey guys, we're going to do a rebuild of the, it looks like a LVS, but it's not. It's the MOJO, the old school MOJO. It looks like somebody already, the dust cap already popped off and they glued it back on. This is the, I think that's, is that rubber? No, that's foam. I don't know, maybe it's rubber. Anyways, we're going to show you from start to finish. I'm not going to bore you with a lot of the cleaning stuff. That's going to be in another video. But I'm going to show you how just dumb this design is. It doesn't do anything. It's just for show. And we're going to make this right. So, alright, so here's the teardown. There's Travis. He's going to do it. And go ahead and use, we like these knives, the snap blades. The whole thing costs like $1. And it works wonders. And the blades from are super cheap. Throw that gasket away too. Don't recycle the gasket unless you absolutely have to. Otherwise you spend all this time and money reconing it and then it looks like shit with a crappy gasket. Gaskets are cheap. And when you buy a recone kit from us, you get it free included. So Travis is going to do his best to cut the cone off so he can save the dust cap. So we've cut the cone because getting the dust cap off is there's a little trick. But now you just you cut out the spider like you normally would, and it's going to be a pain in the butt because you got to undo the second one. So we got to totally unbolt this thing and take it apart. Some quick notes. Notice this is really for show. A lot of this stuff. It's got the little tab right here. I don't know if you can see that real close. But and the clamp, the spider clamp. That's all for pretty. I know some companies like American Base actually have screws up underneath here and it bolts into place to make it awesomer, but it really doesn't do anything except for cut down on wait time when you're gluing it together. So we'll talk about that more. Okay, so the way we got around it was we actually had one person lift up and then we cut down with a really long blade into the second spider that's way down in there. So, and as you can see from here, they got 2 spiders on the lower landing and then 1 spider on the upper landing with the leads. This is a really long former, which makes it even harder to find and buy because most speakers don't use a former this tall. We actually have this original former. The speaker was actually designed by a company called NCA Labs out of California, Northern California. And this is based on the TC9 Plus motor, which is a dual 1-inch slug motor. It's pretty common. Travis, will you get that off? Oh, it's triple. There's a surprise. It's actually a triple slug. So, but it looks like a triple 3/4 inch. Then it's got a normal 1/2 inch top plate. This is a standard 40 millimeter wind height, which is actually quite short for a lot of the coils that have been used on this similar motor. It's got an extended back plate, which is to keep it from bottoming out, but the coil will never reach that far because the spiders limit the excursion to just about 2 inches max. So yeah, so you bought this awesome woofer, but it only moves 2 inches. So there's no need for that second basket, and that's why, not that it's a piece of junk, it's just a lot of flash for a lot of nothing. And so what we're going to do is actually pull the frame off, which we had to cut out the spider first, and then that gives you access to the bolts here. You take this off, and you can see on some of the bolts that we were not able to get off, they're right underneath the arm, so you don't have access to them, or it's very tough. When you try to take the bolts off from the bottom, the heads spin. So, but we're going to go ahead and remove that and break this down to just the motor, and then we'll show you cleaning techniques on the motor and then cleaning techniques on the frames. Okay, we got the top frame off. We did all these bolts off. This is just a big piece of steel or aluminum or whatever the fuck that is. This, they used the same clamping method. This one they used a little spacer in between. We'll go ahead and chisel that off. We've taken out the hardware that attaches it to the motor. This is one mistake that a lot of people make, is they'll use a mallet to hit here. First, if you're going to do that, hit on the ribs where it's stronger instead of in between. But I don't recommend doing that at all. I recommend just getting a chisel and a hammer and prying it away, because sometimes when you hit this the glue has been weakened by really riding the motor hard, or the subwoofer really hard, and so it gets really hot. And when it gets hot, it weakens the bond, the glue that holds that top piece on. It's just a good idea not to test it. So, and another look at this motor. It's an even plate. It doesn't have the pole piece, the risen pole piece that you see that's popular. I'll show you those on some Rockford subs. I guess it's popular right now, even though it doesn't really make much of a difference at all. But we'll talk more about that later. Alright, so that came off pretty quick. There's a little bit of residue that you can get off with maybe some acetone. If you can't get it off with acetone, you can grind it, but make sure you lay down some primer or some paint to cover that steel up, because you don't want it to get rusty after a while. The other thing is we're going to clean the gap right here. I'm going to show you how to clean the gap. This is a Robot Underground gap cleaner kit. This is jumbo sticks that you get from, make sure you use the jumbo ones and not the regular ones. Jumbo craft sticks from Walmart. About $3 a box. Make sure you get the big box, the 300 count. That's the only one that's worth it. The little one will work in a pinch, but you pay way too much for it. This is regular painter's tape. I like to use the 3M stuff whenever I can. It's like $6 a roll, but it's totally worth it because it gives you the right amount of stick. You can use other tapes that use a 2-inch width, which wraps around this thing perfect, like packing tape or masking tape, but I don't like to use those on a final clean because they're sometimes fragile and they'll break. But if you have, like, if this thing is like filled with just ferrous material and dirt and just gunk, remember to first blow it out first, because there may be leftover residual crustiness from the coil dying. This stuff, it shows up. So you always want to blow it out first. You put it up on angle, and you have a needle attachment, which I'll show you here in a minute, and you just want to go around and blow all the debris out of there and blow this thing down and just kind of, you know, get all the debris away from it first, and then we'll show you the gap cleaning. Alright, so this is basically a cheap gun from Harbor Freight. I don't even think they make it anymore, but I really like how small the needle is on this thing, because it goes right into the gap and gets all that shit out.
Chicken bone neck, cocksucking Jew. Niggas like her, motherfucker, coon. Chicken bone neck, cocksucking Jew. Niggas like her, motherfucker, baboon. I wanna hurt those who I'm jealous of. I'm an angler.
You want to blow it off all around, because sometimes you get magnetic material here, or you might have something on your grinding bench that it picks up. You can also remove it with packing tape. It's real cheap to remove the outside ferrous material. But basically that's a primary clean gap, but you can see sometimes there's like pieces of ferrous material in there that's magnetic, and what we'll do is we'll use the tape stick to go ahead and get that out. No pipe cleaners needed. Alright, so what you want to do is pull off about, I think it's about 8 inches of tape, and then you wrap it backwards around the stick so that the sticky side is out. And it's kind of like rolling a joint, where it takes practice, and you fold the sides over and then you fold the ends over, and you have a really, you know, semi-sticky tip. And then you go ahead and just clean out the gap. You can start with just general going through it and pulling out the pieces like he's doing. You want to use several applications to go through and clean it out really clean. Use a flashlight to shine in there. Using a flashlight to actually clean the floor is what I learned in the military, and you can see all kinds of particles when you get that profile light on it. And so Travis will do that here in a minute, and it'll be sparkly clean and ready for recon. Okay, we're out back. Real quick, this is the taller T-yoke or pole piece that you see is very popular. This is on the Diamond Audio D6 motor, which is now the TX series. This one's been painted. Great motor, Y35 material, very strong. This is the Rockford, I think this is probably a T1 motor, and this has a really tall top plate, and we got a whole bunch of cool Rockford motors in the other day. That will be really fun to work with. This one we're going to go ahead and, here's the frames from inside, just with a chisel, pop those off, and then you basically use a 2-inch grinding wheel and a grinder like this. We use the good 3M pads. 36 grit, very, very aggressive. And those work great on removing all this material here and the material here down to the metal. If you're doing a lot of these, the best way is actually on a lathe, because then you get a nice even surface. But if you're really good with a grinder like we are, it's a snap. Alright, so we managed to get the terminals off, and we detached the top assembly, the spider spacer and the spider ring clamp. You can salvage those, but we sell those for really cheap, so you can buy more, so it's not a big deal. There's a bit of a layer of foam, if you can see that. You can grind that off directly, but it makes a hell of a mess, so if you can cut off a lot of it, it helps get some of that waste off ahead of time. So what you want to do is just use a regular standard box cutter like that. With the triangular blade, you want to cut away from you and just sort of skim along the bottom and cut that foam off like Travis is doing. Presto. So now it's ready to go. We want to grind down to the metal, even though they used like a rubber cement to bond to the paint, which is cheaper, because when you're doing production you don't really have time to grind that, but we like to use CA on these two joints, and so we want to bond directly to the metal. As far as grinding goes, basically you want to have an angle grinder like this. Is a 90-degree angle grinder. These are like $50 ones that we pick up from our abrasives manufacturer. They just screw into place. I can do that with one hand. It'll work while I'm injured. Sweet, I'm badass. So what you want to do is basically, if you're right-handed, you want to go 12 o'clock, and you want to focus on the area that needs to be glued and just kind of bounce back and forth and ride the grinder. You're just supposed to guide it, not force it, because if you force it, it's going to kick back on you and it's going to suck. So if you just let it sort of ride the surface and let the gravity and the weight of the grinder sort of guide you along here, it'll come off real quick. If you're left-handed, you're going to grind this way at 6 o'clock and do the same thing. So, and if you're like me, where you're able to do it with both hands, or with either hand I should say, it helps the fatigue if you're doing a whole bunch of them. So sometimes the guys back here are back here for days, depending on what shift. Alright, the frame is ground. So it looks great. Again, like I said, the best method is actually using a lathe, and that way you can control with a lot of precision of what gets ground off and what doesn't. This just made like an orange mess over everything, my shirt. So we're going to blow this off and bring it inside. And basically we've used the flashlight to clean out any debris that we see near or even far down in the gap. That's the boot. The old dust cap we'll pull off here in a minute, and then we got the frame we're going to go ahead and bolt on. One thing I would like to say about hardware is Phi, I noticed, doesn't use any goop here. They don't use any adhesive material, which I like, because that way the frame comes off real easily, doesn't make a mess. But the goop is there. It's not there really to make a good seal. It's there to keep the frame from falling off. You may think it makes a good seal, but it doesn't. What keeps a good seal is a tight screw. So you want to have a tight screw, and you want to use Loctite or just a drop of CA or glue, like a lot of manufacturers do, on the screw to keep it in place. Now Phi, I noticed, I don't know if it was because of supply or if they do it on purpose, but we'll say it's on purpose. They use stainless hardware, which I think is great because it's non-ferrous, meaning it's non-magnetic. So while you're screwing this in, especially on a live magnet, I mean, when you're doing manufacturing, you don't work with live magnets, but it's a good idea just not to have little pieces of ferrous material around to get into the gap, because that can screw up a whole recon kit or even a building process. So if you use regular hardware in here, which is it's cheap and it's magnetic, sometimes little pieces that get stuck from the bit that's putting it in place, or you strip it or whatever, they can get in the gap, and then when you magnetize, it'll be stuck inside the gap, and once you have this spider over here, you can't get it off. So it kind of ruins the whole process. So as a rule, we like to sell and use the stainless hardware. So this was built by NCA, so it might have standard hardware, which is Q20 typically. On some of the SoundStream motors we got in, they use a 1032, which are SAE or Imperial standards. Typically, if you can see it on there, the M6 by 12 millimeter is the most typical screw, because most of the motors come from China. Okay, now with that said about the hardware, sometimes you don't have the luxury of getting stainless hardware. So in this case, we're actually going to use the old hardware, which is Q20, and we're going to go ahead and put them in, tighten them down, glue them down into place, and then we're going to go back and clean the gap again a final time. Another quick note on hardware. Notice this is a flat head, and so it actually sinks in there further than you might think. A lot of people want to use longer hardware because they relate that to something that's stronger. You got to remember though, you don't want to use any hardware that's longer than your top plate, because then it'll push the top plate away from the magnet when you go to try to He-Man it into place. Alright, so short screws are good. Make sure you use the proper screw, which is a flathead if you can. If you can use stainless, that's even better. If you can't, if you ever dissect a bunch of subwoofers, you'll find out that they use all kinds of hardware. Because sometimes, even though you're buying 10,000 pieces, you run out, and sometimes you need to use something else in place of that. And that's why sometimes you'll see inconsistencies in manufacturing like that. Okay, we're all ready to go. Now what we also did was go to the base of the cone and cut around, so that you end up with just the dust cap and then a bunch of crap on the outside. You can later pick this off with a razor or grinder or whatever. Be gentle with those things, but you can totally refurbish it and make it new. That's the old coil. This is the new coil. We're going with a little bit of extended wind height. This is the coil for the T.C.O.Z 3 HP. Works perfect. The customer wants it D4, and that's what we're giving them. What you want to do is now you want to center this, concentrically, so that it floats in that gap. That's the gap right there. And then you also want to center it, let me put it this way, the center of the coil here this way, like widthwise. So right about there, you want to put at the center of the top plate. So it should be down about that far. We're going to use rulers and everything like that. What you do is you just measure this, you measure the top plate, and then you find the center, and then you mark it with a marker, so that when you load it in like this, you can barely see the mark. Or, however you do it, but that's what you want to get it centered. So Travis is going to do that now. We're going to use our standard 8-inch spider with heavy leads. Actually, we might use the double leads. Not that it, in this case, increases power handling, it just makes it look more badass. So, and you got a little room to spare, because on the 15-inch frame, the distance between the top of the spider and the cone is quite a bit, so you can have a lot of crap like this, or even double spiders, or however you want to do it. Alright, Travis has got it in there. We're going to actually use a shim. This is a sheet of Teflon, and it comes in different thicknesses. You can get it from McMaster Car. Don't complain about the expense. It's actually quite affordable, considering if you're going to do a lot of recones. If you're not, just use manila folder like you've been using, or business cards, or some sort of sturdy paper stock to help you shim it equally. Now, when we get these coils made, we actually make them a little bit longer so we can do that. This really helps with production, is we fold them over the top so that then we can put the spider over without having to dig the leads and bending them back and forth and all that stuff. So also, when you're working with aluminum coils, it's good just to make extra windings on the tinsel leads, and all the contact you can get just makes for a better connection. Alright, so here's the coil. He's got it all spaced out, measured, and level. If you notice, sometimes you'll notice a little bit of bending, which is natural on the spider. There's not really anything you can do about it. And remember, there's going to be a little wiggle room inside the gap. That's what's great about having a well done gap. So sometimes when you deal with those digital designs parts, they cheat and use a smaller magnet, but they use a tighter gap. which sounds great on paper, but when you actually use it, you end up with a lot of rubbing and some wear and things like that. But anyways, what we're going to do is go ahead and put an epoxy bond right here, bead right there in that joint, and then we're going to let that sit for a couple hours. Okay, so our coil is all jizzed up on the bottom. I got the top soldered, cut, ready to go. We got our spacer that's going to act as a clamp on top of the spider landing. I've also swapped out the terminals for these types. Sure if you can focus on that. These are the same types that Phi uses and a couple other brands. We use extra long ones because we use them in the TI frames, but this is the original, and it's not awesome for dual leads, so these are way more awesome, so we decided to use those instead. So, but you want to mock up all your parts before you do it. I've bent the leads up so it makes it easier for when we got to put this on. You come over to the other side, and then we're going to put clamps down all around. And so you got to put CA on first. We do a CA bond on the bottom. Then you put your top assembly in that's already shimmed. Here's your shim. It's, in this case we're using, I think this is a 0.75 millimeter. So poke that down at the bottom. Scooch it in like that. Fits nice and firm. We're going to do a clamp. Put jizz down, jizz on top, clamp ring, clamps, and then we'll come back and do an epoxy to double bond this spider, and then also to encapsulate the leads so they don't slap around and move and break, and then we'll be ready for the cone. Alright, as you can see, I got the clamps on, and I'm just about to give it a spritz with the accelerator. You don't have to. A lot of people get crazy with the accelerator. This is going to cure overnight, so I don't really need to, but I like using the accelerator because it prevents fuming that you get with CA sometimes. Also, just so you know, CA never belongs on the inside of the spider. You can do it on top of the cone once you put the cone on to hold the cone in place, but always epoxy on this section. So, because otherwise, CA, when it cures, it has like crystals that grow out like spikes, and then after about, I don't know, 5 months, 6 months of use, it'll eat a hole right through the spider. Boom. So we know because we've done it when we were first learning how to make subs, but we don't do that anymore. And if anybody tells you to do it, they are wrong. One more quick note about CA: when you're working with it, you do not want to have the fan going. You want to have it off. Yeah, the fumes may get to you a little bit, but you don't want it to cure. It cures fast enough, even though it's slow cure. You want as much time to work with it as possible. Then once you got the clamps on, then you can turn on the fan and spray the accelerator. Okay, one soldering tip is to make sure you really want to test your solder joints as you go. I tested before, but I didn't show you. And what you want to do is basically plug it in where the wires go, because that's where that's the end lead, the end part of the lead. So we got 4.0, which is right what I measured originally on the coil. So that tests your solder joints. Go ahead and trim these off. Do the same thing to the other side. Sometimes these posts will go bad, and that's the argument people make about using direct connect, but you can have the same problem with a direct connect, is that you have a bad solder joint. So sometimes you can sit there, and if your impedance is, or your resistance I should say, your resistance is too high, you can sit there and solder on it and watch the resistance drop as your solder joint gets better. So there's a lot of videos you can watch on soldering, and this is not one of them. Okay, we got it all soldered up, all jizzed up, ready to go. I ended up deciding on using the hard times cone, which is what the customer wanted in the first place. But also it's midnight, and I didn't want to run the saw to neck out the carbon fiber cone, or glass fiber cone I should say. So I've necked it out a little bit. You can see this. I've taken a tool, usually a soft round tool like a screwdriver or something, like that. You use the the shaft. Use the shaft to come inside and sort of open the wound, I guess you could say. And so you want to test fit it and make sure it goes on pretty easy, because this is the time that you don't want to have problems getting your cone on, because you're going to be having a live bead of CA on there, so you want to be able to get it on pretty quick. So I don't have four hands to do this with the camera, but basically what I'm going to do is lay down a bead of CA around here, put the cone on, put the clamp on, or the ring I should say, 15-inch ring. So that's going to go on top of that, clamp that down real quick, and then we're going to put a bead of CA inside to hold the cone in place, and we're going to let that sit overnight. Alright, it's morning, it's all cured. We're going to go ahead and remove all the clamps and the shim, and then we're going to test it out on the butt kicker. Good healthy 1000 watts. Break it in and make sure everything's working okay, and then we're going to trim the former and put the inner cap on. Okay, we got it hooked up. We got our badass speaker cable, Oxford OSC2. Make sure you test each coil individually in case one's bad. Even though you did ohm it out, it's still good to test it. Alright, so we got to go in free air. Looks pretty awesome. Playing about 20 hertz. You want to sweep it a little bit and make sure there's not any rubbing or buzzing at the higher frequencies, because that could be annoying. Alright, everything tested out good. What you want to do is I use a snap blade because they're cheap and they work awesome. You want to make sure the one you're using can be a little beat up, it's fine, because you're going to be cutting aluminum with it. But after you're done with it, it's going to be trashed. So basically I just start here, or you can start in the seam right here. You see that little notch? So you can start in the seam if you want, or wherever. But you just basically want to saw into it. And then you go down to the base, and then you just go around. Alright, the former's cut. This is just a really thick, it's not really thick, but it's a thick, just a regular dust cap, and you can either use it inverted or convex right there, depending on what you want to do with it. In this case, Memphis actually used a support system below it, so we may want to use maybe not this one, but like another one where we actually have this inverted, and then we have another cap inside to get the right height to support the outer cap. So I like using an inner cap just because I think something should be really sturdy and really glued or epoxied on there really well to hold back the inner pressure of the cabinet. This one actually has quite a bit of surface area right here to glue to, but I don't trust outer caps, so I like to use inner caps. Okay, I've go ahead and I've already set the inner cap, or I should say the secondary cap here inside the inner cap. This is to support the outer cap, which is the factory one. When I was seeing if the height was going to be right, because you want just a little bit of contact onto it, basically what I did was I licked here or put some spit here, and then you put it down and then pull it up, and if it was wet then you knew that it touched. So it touched just a little bit, so what I'm going to do now is finish this off with some rubber cement and put a gasket on it and call the customer. So it'll be ready in a couple hours. Although you should basically let it sit for 24 hours to be fully cured of everything, you know, the epoxies, the CA, the everything. And also, before I put that cap on, I'm going to go ahead and bring it over to our little test PC, where we got the we just used the standard Dayton audio from Parts Express. Woofer Tester 3 works great. Get the teal small parameters for the customer so they can build the perfect box, and then that'll be that. Also, this is the time you want to badge your subwoofer. So in case anybody wants to contact you or something like that over your work, or if you want to hide warranty numbers of when it was made, you know, like you can put the date here or something like that. Some people mark the underneath the spider so you can't change it or anything like that. You can engrave something or whatever. T.C.O.Z used to, like on the Storm motors, let me find them right here, they would write like the date, you know, of when it was produced, which is kind of cool, just to give you an idea of how old something is. Those were like made back in 2001, but you know, recon them 100 times if you want. They're great. Another thing, guys, when putting on your logo, we practice something where we put the terminals left and right. One little thing that we found was that when you mount a woofer with the terminals down, sometimes when loading it or unloading it from the box, it can slip and bang the terminals, they break, and then your whole subwoofer is basically ruined because of an oops. So we like to go left, right. So like this, you got your mounting holes centered, then you can center your logo off of those, and you can use rulers or however you want to do it, or just eyeball it. So there we go. That does equal epic win. Hey, thanks for watching Robot Underground, and send in your requests and emails for specific product or specific videos on building your next great subwoofer. Thanks.